Lesson 12.3, found on page 481 of your big book, is all about dot plots and frequency tables. Our essential question: how can you use dot plots and frequency tables to display data? A dot plot is a number line with marks that show the frequency of data. Frequency is the number of times a data value occurs. So in other words, frequency is how often. All right, Hannah is training for a walkathon. The table shows the number of miles she walks each day. She has 1 day left in her training. How many miles is she most likely to walk on the last day? So we're going to make a dot plot. We're going to draw a number line. Well, first, okay, what are we supposed to find? The value that occurs the most often. Occurs most often, because we're looking for what's most likely to happen. So the one that shows up the most often is our most likely. All right. So first we're going to draw a number line with an appropriate scale. All these numbers are under 10, so our scale can just be 1. 1, 2, 3, 4, 5, and so on. We don't have to do count bys with 2s or 5s or 10s. If these numbers were in the hundreds, we would adjust our scale for that. Maybe this would be 100, 200, 300, and so on. It's not. All these numbers are under 10, so we can just do 1 through 10, and that's an appropriate scale. Numbers vary from, let's see, 1 to 9. I don't see anything bigger than 9. So use a scale from 0 to 10. For each piece of data, plot a dot above the number that corresponds to the number of miles Hannah walked. Complete the dot plot by making the correct number of dots above the numbers 5 through 10. All right, so they found 1, 1. So I'm going to cross that out so I don't repeat it. They found 4 2s. So 1, 2, 3, 4. 3 3s. 1, 2, 3. 4 4s. 1, 2, 3, 4. All right, how many 5s? I see 1, 2, 3, 4, 5. Ooh, a lot of them. Okay. 1, 2, 3, 4, 5. And how many 6s? I see 1. And I don't see any 7s or 8s. All I see now is 1, 9. All right, that's everything. We found them all and plotted them all. Okay. The number of miles Hannah walked most often is the value with the tallest stack of dots. The tallest stack in this dot plot is for 5 miles. Because it goes all the way to 5. This is our tallest stack. So the number of miles Hannah is most likely to walk on the last day of her training is 5 miles. All right, so communicate. Okay, why is a dot plot useful for solving this problem? Okay, well, it makes it easy to identify, it makes it easy to see the data value that occurs the most often. Okay? It's easy to tell this one's the tallest, this is the most likely. It makes it easy to see which data value, which number occurs most often and therefore is most likely. Okay, We can tell which one occurs the most often and therefore which one is the most likely to show up, to be used. All right, a frequency table shows the number of times each data value of range. Let me start that over. A frequency table shows the number of times each data value or range of values occurs. So this is our frequency table. A relative frequency table shows the percent of time each piece of data or group of data occurs. All right, so Jill kept a record of her workout times. How many of Jill's workouts lasted 90 minutes? Okay, so we've got our frequency table. So we don't have to make it. They did that for us. List the workout times in the first column. These are columns. Record the frequency. Oh, I see. They wanted us to make a table here. So this is the one we were supposed to draw. List these values in the first column. Record the frequency of each time in the frequency column. There we go. Now complete the frequency table. All right, so 30 shows up 7 times. Is that how that works? So 1, 2, 3, 4, 5, 6, 7. It does show up 7 times. All right, so now 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Shows up 11 times. All right, 90 shows up. I'm going to go a different direction. 1, 2, 3, 4 times. And 120 shows up. 1, 2, 3, 4, 5, 6. 6 times. All right. So blank of Jill's workouts lasted exactly 90 minutes. So just 4 of Jill's workouts lasted exactly 90 minutes. All right. The table shows the number of laps Ricardo swam each day. What percent of the days did Ricardo swim 18 or more laps? Okay. Make a relative frequency table. That's here. So this is the data. This is the frequency table that we were supposed to make, but they started it for us. Determine the equal intervals for the data. List the intervals in the first column. So 3 to 7 laps, 8 to 12 laps, 13 to 17 laps, 18 to 22 laps. Okay, so we need to find all the numbers that range from 3 to 7. So that's 1, 2, 3, 4. So 4 in this range. Okay, now we've got 8 to 12. So that's 1, 2, 3, 4, 5. Oh, 6. Sorry. 6. Okay, here we have 13 to 17. 1, 2, 3, 4, 5, 6, 7. Okay, so there's our 7. 18 to 22. 1, 2, 3. Just 3. Okay. So now we have a total of 1, 2, 3, 4. 1, 2, 3, 4, 5. So we have a total of 20 data points. So 4 out of 20 equals 0.2 or 20%. Here we have 6 out of 20, which equals 0.3 or 30%. All right, so now let's do 7 out of, whoops, sorry, it should have been the other way around, sorry. 7 out of 20 is 0, so that's 360. So that's 0.35 or 35%. Now we have 3 out of 20. Let's move it down here. So that's 0.31, or not a decimal, sorry. Bring down another 0. So 15, 0.15 or 15%. All right, so we finished our table. Here we go. Divide each frequency by the total number of data values, which we did. The total number was 20, and we divided each of these by 20 and got our percents in the relative frequency column. Complete the relative frequency table. We did that. So Ricardo swam blank laps on blank, let's see. So Ricardo swam 18 or more laps on, let's see, it's 15% of the days. So out of 100, 15% is not very many. He's not doing it very often. Okay. Here we go, one more. Complete the dot plot. So we've got ones, 1, 2. We have twos, we have 1, 2, 3. Threes, we have 1, 2, 3. Fours, we have 1, just 1. Fives, we have 1, 2, 3. Sixes, we have 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. Sevens, none. Eights, 1, 2. Nines, 1. We have 1. Tens, we have 1. 11, we have 1. Did I miss an 8? I did. There were 3. This is why I cross out my data, so I catch those errors. All right. So what was the most common distance Lionel biked? How do you know? Well, the longest was 6 miles, and we know that because it has the tallest stack of dots, right? So we would say 6, oh, I'm sorry, it's in kilometers. It's 6 kilometers, not miles. Because it has the tallest stack, right? Okay, so now you make a frequency table and use these intervals. So there's 1, 2, 3, 4. So you're gonna go like this. So 1, 2, 3. We're gonna go 1 to 3, 4 to 6, 7 to 9, 10 to 12. What should we have at the top? Ricardo's lap swimming. So this is Lionel's distance, Lionel's biking distance. Okay, so then you figure that part out. So this was what? 1 to 3 is 6, 7, 8. 4 to 6 is 6 was 1, 2, 3, 4, 5, 6, 7, 8, 9. 7 to 9 was 1, 2, 3, 4. 10 to 12 was 1, 2, 3. All right, now we're going to write a relative frequency table. So what you're going to do now is it's the same. It's this. We've got to label everything. 2, 3. So we know what this data set is about. So this is, again, Lionel's biking distance. And we're going to go 1 to 3, 4 to 6, 7 to 9, 10 to 12. This was 8, 9, 4, 3. Now we're going to figure out the percents. This last column should all be the percent. So what is our total amount of data? Well, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 25 data points. Okay, so we have 8. So here we have 8 divided by 25. Here we have 9 divided by 25. 4 divided by 25, and 3 divided by 25. So the 8, I'm going to use this space up here. 25 does not go into 8, but it will go into 80, what, 3 times? 5 goes into 50 twice. So this one is 32%. And then keep going from there. 25 goes into 9. Again, it would have to go into 90. Again, it would be 3 times. 75 would be, what, 150. So that'd be 1, 4, 5, 6. So 36%. And so on. Okay, keep going, filling this out. And that's how you do a frequency table and then a relative frequency table. Relative means percent. All right, good luck.